All right, so we're on page 17 of your packet. Now, this is what we call a big picture problem. So, it's basically a lot of angles built into one circle. Where typically how these work is that they give you enough information to start, but then your job is to find everything else that they ask for. All right, so we're going to do this first one together. And by the way, I will give you a big picture problem on your test, so pay attention. So arc GE is x, EF is 2x plus 20, FC is 3x minus 40, and CG is 4x minus 20. So if I go around and mark these, GE is right here. We're going to call that x. EF is here, and that is 2x plus 20. FC is here, and we're going to call that 3x minus 40. And then CG is the rest of it. And it is 4x minus 20. Now, with big pictures, you want to get it so you have at least a couple of arc or angle measures to start with. And then you can work your way around. So I basically got the full circle worth of arcs. So the question is, how can I find these arc measures? How can I solve essentially for x? What should I do? Right, add them all together and set it equal to 360 to solve for x, because after that, I can plug in for x and get the arc measures. So I have x plus 2x plus 20 plus 3x minus 40 plus 4x minus 20 is equal to 360. So if I combine like terms, x plus 2x is 3x, plus 3x is 6x, plus 4x is 10x. 20 minus 40 is negative 20, minus 20 is negative 40. And it's equal to 360. I then add 40 to both sides. So 10x is equal to 400. Divide by 10. X is equal to what? 40. So remember, x is also equal to GE. So the arc measure for GE is 40 degrees. Now, to find the other ones, I'm just going to plug back in for x. So I have EF is equal to 2x plus 20. So 2 times 40 plus 20. So that'll be what? 100. So arc EF is 100 degrees. FC, it'll be 3 times 40 minus 40. So that's 120 minus 40, which is 80. So that'll be 80 degrees. And then finally, GC or CG, however you want to put it, it's 4 times 40 minus 20. 4 times 40 is 160, minus 20 is 140 degrees. So that's 140 degrees. Now, Now, here's kind of what I tell my students to go about it from here. Basically, you pick a type of angle, like a subtype, so a bow tie, beaks, or inscribed, or central, and you find the angle measures of all the ones that apply to that category. So, just pick a category. What do you want me to do first? Beaks, bow ties, or inscribed? All right, let's do beaks first. So, I'm going to list these as beaks. So, wherever you have space, just do as much as you can. What is one angle that's a beak? Someone name me the number of the angle that's a beak. I just need the number. Yeah. Just look at the little numbers. Just tell me what number. 1. 1 is definitely a beak. So right here. So remember, beaks, the formula is arc B minus arc A over 2, where B is greater than A. So if I look at angle 1, I'm just going to draw it so that you can see where it is in the circle. All right. What's the big arc that connects to angle 1? So what's the ice cream on the ice cream cone? What's the degree of it, I should say? So here's the cone, guys. Where's the top of the ice cream? It's what? It's 80. It's right here. FC, the blue. That's the top of the ice cream. So that's equal to 80 minus, what's the bottom of the ice cream of that cone? It's what? 40. Good. It's the yellow. And then we divide it by 2. So 80 minus 40 is 40 over 2. So angle 1 is equal to what? 20 degrees. So I'm going to write it here. I'm also going to write it in the picture because we may need it for later. All right. What's another beak? There's one more. 8. So 8 is also a beak. So 8 is right here. So it starts here, goes here, and then it ends here. So angle 8 is also a beak. What is the top of the ice cream cone? It's what? So FC is the bottom of the ice cream cone. So the smaller one is 80. What's the top of the ice cream cone, though? It's what? Not just 140. So it goes from here to here. It's 180. It encompasses both the pink and the yellow arc. So you have to add 140 and 40. So it's 180. So 180 minus 8 is 100 divided by 2. 8 is what? 50 degrees. So I'm going to mark it on the picture. I'm also going to mark it on the spaces. Now, that's it for beaks. Those were the only 2 angles that were like truly outside of the circle. All right, now pick another subtype. All right, let's do bow ties. All right. Someone name me one angle that's a bow tie. Say it again. All right, 15. So right here. Now remember, the formula for bow ties is angle A plus angle B all over 2. So in other words, you're looking at both 15 and 13. You're looking at the intercepting arcs of both. So for reference sake, here's where the bow tie is. So what is the arc that intercepts 15? What's the degree? It's what? So guys, here's the ice cream cone. Where's the ice cream? It's at 40. So we have 40 plus. Now look at 13. Here's the cone. Where's the ice cream? 80. And then divide it by 2. So this will be 120 divided by 2, which is what? 60 degrees. So 15 is 60 degrees. Now, not only is 15 60 degrees, what else is also 60 degrees? 13. So 15 and 13 are the same angle. So you fill that in for both. What's another set of bow tie? 14 and 12, and they're going to be congruent to each other. So, what's the ice cream for 14's cone? 100. What's the ice cream for 12's cone? 140. Divided by 2, that'll be 240 divided by 2, which is 120 degrees. So both 14 and 12 are 120 degrees. That's all my bow ties. So the next subset that we haven't done yet is inscribed. All right, I want to do these like way up here. And remember, inscribed, the formula is simply you take whatever the angle is equal to the arc over 2. So remember, inscribed, the vertex is on the circle. So someone name me one inscribed angle. What? 9. All right, so 9 is right here. Okay. Now this is a little bit of a deformed cone, but what's the ice cream on it? So it's kind of like a halfway melted cone for 9. So what's the ice cream for 9? It's what? Not 40. So it's right here, guys. What arc is the only arc that's kind of between that angle? 80. So I'm doing 80 divided by 2, which is 40. So 90 is, or 9 is 40. So make sure you write in both places. All right. What's another one? What? 10. That's another one. So 10 is right here. All right. What's the intercepting arc of 10? Someone besides Abby. So besides Abby, what's the intercepting arc of 10? 100. So 10 would be 100 divided by 2, which is what? 50 degrees. All right. Someone besides Abby, name me another angle. 6. All right. So 6 is right here. All right, someone who has not talked yet today. What's the intercepting angle of that arc? Intercepting arc of that angle. 140. Good. So 140 divided by 2. That will give me what? 70 degrees. So that was 6. And it's 70 degrees. All right. Someone else who has not talked yet. Give me another inscribed. There's still a couple more. What's another inscribed? Come on, guys. What's another inscribed? 7. It's actually not. 13 is. No, we already found 13. 16 is, yes. So 16 is right here. So 16 is right here. How can I find 16? What's the ice cream on top of 16's cone? 80. So I'm going to do 80 divided by 2. So 16 will be the same thing as 9, or 40 degrees. So the great thing about these guys is that at some point, you'll start getting repeated answers. Especially when they start intercepting the same arcs. What's another one? It's what? 17. Yes, 17 is. So 17's right here. What's the arc that intercepts 17? 100. Good. So it's going to be the same thing as 10. So 17 is 50. What's another one? 3 is also 1. So 3 is right here. What's the arc that intercepts 3? 140. So 3 is going to be the same thing as 6, which is 70. So 3 is 70 degrees. Still got a couple more. 4 is also 1, so 4 is right here. What's the arc that intercepts 4? 80, so it's going to be the same as 16 and 9. So it'll be 40. What's another one? 5 is 1. What's the arc that intersects? Nope. 40. So angle 5 intersects 40, so we divide that by 2. That would give us 20 degrees. So 5 is 20 degrees. All right. And there's one more. 11. What does it connect to? 40. So it's the same as 5. It's 20 degrees. Now, the last couple of angles don't actually have a special property. They are what I call the other. So in other words, they use other properties. Whether that be the triangle sum property or linear pair. In other words, they're going to be something equaling to 180 of some sort. So, let's start with 7. Now, 7 is not an inscribed for the sheer fact that inscribed is either two secants within the circle or it is a tangent and secant. But since this is clearly not tangent because it keeps going and this is a secant, this is not an inscribed. But I can find 7 pretty easily if I look at this shape right here. What's that shape? It's a triangle. Do I know 2 out of the 3 angles in that triangle? Yes, I got 40 and 50, which is 90. So, what's the measure of 7? 90 degrees. So I found angle 7 because it's a triangle. So you do 180 minus 40 minus 50, and you get 90 degrees. Now, 2 and 18. One of the two you got to use since they're in the same triangle. You can't really use triangle sum theorem, but you can use linear pair properties. So if we look at 18, which is right here, it shares a line with 16 and 17, meaning that those 3 angles have to add up to what? 180. All right. So in other words, I'm just subtracting 50 and 40 from 180. So angle 18, it's a linear pair. So I'm doing 180 minus 40 minus 50 still gives me 90. Thus, 2, I can either use the triangle from 118 and 2, or I can use the linear pair formed between 2, 3, and 4. Either way, it'll give you about the same thing. All right. So, they both will give you the exact same thing. So, I'm going to do the triangle way. So, I'm going to do 180 minus 90 minus 20. So, 180 minus 90 is 90, minus 20 is 70 degrees. So, angle 2 is 70 degrees. And thus, we have found every angle in our big circle. Now, is it a lot of work? Yes. But if you just take it one step at a time, I just break it up into its categories. And it really doesn't matter the order. I usually take care of all the special types first. So the bow ties, the beaks, and the inscribed. And then whatever's left over, that's when I start using other properties. So triangle sum theorem and linear pairs typically. All right. Any questions on that one? All right. Look at the next page. So, what I'm about to do is I'm about to have you guys try this one on your own, but I want to make sure you got to all your arcs. So, for this one, they gave you all your arcs except for one, SQ. All right. How can I find SQ? Add them all up, subtract from 180. So, for SQ, I'm going to do 360. That's what I meant, 360. So 360 minus 150 minus 40 minus 85 will give you what? It's what? 85 degrees. So this arc right here will be 85 degrees. Now, if it helps, do what I did on the previous page and highlight your arcs, or, sketch them in different colors or something, just so you can see clearly where those arcs will be when you start doing your other types. So what I'm going to do is I'm going to give you guys a couple of minutes. I want you to pick a place to start. It doesn't really matter where you start. In my opinion, pick a category. Okay? Do either beaks, bow ties, or inscribe first and just go through the categories. Then whatever you have left over, that's when you start using your triangle and your linear pair properties. All right? So I'm going to give you guys a couple minutes, and you can work with your group mates if you want, but I want you to try this one. See if you can get it. So again, pick a category and roll with it. So pick a category, do all the ones you can find in that category, then move on to the next category. So that geographic organizer will help you. So again, pick a category, find all the ones in that specific category. Guys, if it helps, I'll leave this one up. Okay. The notes that we're doing for the rest of the class after this is your journal stuff. So just check OneNote and stuff.
Okay, how many journals?
I'm shooting for at least the one of them. It may be one or two, but I'm thinking it's only going to be one. Guys, I know it can be tedious, but just give it a shot. Because again, you're going to have one on your test. And it's like a 10-point question. Come on, guys. The biggest thing with this, you cannot give up. You've got to think of places. Try it. Without this. And then you so reality. Just no, you might get a 0.5. Guys, I will say for this one, you might get a 0.5 as an anchor. So they run off that line. Get ready about 5 more minutes. Start talking to Brittany.
So next.
So that graphic is just a recap of all the theorems that we've been through. It's just all in place.
Actually, I think this is just
Big circle. Is it the big circle? Like that's why I tell them, like, you gotta do it piece by piece. Like I just say, knock out all the beaks first. Knock out all the bow ties first. 3 more minutes. So they're in for a rude awakening because it's your I've told them before, like, if you sleep on here, that's your prerogative. I'm not waking you up. And if you fail this class, that's your prerogative. I'm not, like, there's 17, 18-year-olds. I'm not babying them. I'm sorry. One more minute, guys. Because when kids email me saying that they completed, that's what I do. I go check. I don't even look at the original assignment. I just go check their name.
just to double check. Just to slide.
It updates all the time.
If it's,
Even if it's considered late, it still updates.
But there has to be something
There's always going to be something in the complete.
right.
The grade can be a 0 because if I put the 10 to duties, but remember, I don't really care about lateness. So. All right, guys, let's go over this. So, we're going to go through each subtype. I'm going to call a name to name me an angle and how to find it within that subtype. So, first person, we're starting with beaks. Let's start with Chase. All right, moving on then. David. So name me a beak and tell me how to find it. Say it again. 11 is, yes. All right. How do I find it? Right. So what's my B and my A? It's what? Okay, so look at it like this. Here's your cone. Look at where the ice cream is. What's the top of the ice cream? So the top of the ice cream right here. It's 150. What's the bottom of the ice cream? Nope, 40. So it's all within this cone. All right. So angle 11, you'll do 150 minus 40 over 2. That is 110 over 2, or 55. So this is 55 degrees. All right. Now let's go with Jonathan M. So what's the other beak? 1. How do you find it? Right. So what's my B and my A? So be what? Good. So for 1, the endpoints are here and here. So the big top part of the ice cream is 150 plus 85, so that's 275. And then the bottom part is the 85 over 2. So this will be 85 over, not 85, 150 over 2, which is what? 75 degrees. So angle 1 is 75 degrees. All right, so that's all of my beaks. Let's move on to bow tie. So name me one angle that's a bow tie, and how do I find it, Lanaya? Say again. So one angle. So what number in here is an angle? Or what number is a bow tie? 17 is. Good. Now, 17 has to be congruent to which angle? 16. So look at the two arcs for both of those. So we do A plus B over 2. What two arcs am I using? 40 and 150. Good. So angle 17 is equal to angle 16. I'm going to do 150 plus 40 over 2. So that'll be 190 over 2, which is what? 95. Good. So 17 and 16 are both 95 degrees. All right, what's the other set of bow ties, Michael? 18 and 19, and they're congruent. What angles? I mean, not angles. What arcs are they crossing? Mm-hmm. Right, 85 and 85. So 18 is equal to 19, which is 85 plus 85 over 2. So that'll be what? Right, it'll just be 85. So this would be 170 over 2, which is just 85 degrees. So this angle's 85 degrees. This angle's 85 degrees. And with that, we're done with our bow ties. Now we're going into inscribed. So someone name me one inscribed angle. Let's go with JJ. 15 technically is not. But it's only one of the few that's not. 5 is. So 5 is because it's with the tangent line. So it intersects at that one point. 15 is not because it's technically 2 secants. So 5 is. What's the arc? It's a little bit of a funky arc. 150. All right. So it's the 150. So how do I find it? 150, and then I do what? Over 2. Now give me what? Good. So 5 is 75 degrees. All right. What's another inscribed angle? Here. Abby. 6 is good. What arc is it overlapping? 85. So I'm going to do 85 divided by 2, which is what? 42.5. So that's one where I said it's okay if you get a decimal. You were going to. All right. What's another inscribed angle? Hunter. 4 is. What's the angle that it intersects? 85. So it's going to be the same thing as 6. So this will be 42.5 degrees. That's angle 4. All right. What's another inscribed Jersey? So it's another inscribed angle. 13 is, yes. Which arc does it intersect? 85. Good. So it'll be the same as 4 and 6. So it'll be 42.5. All right. What's another inscribed Zoe? 14 is. What does it intersect with? Say one more time. Yes, correct. So it's going to be the same thing as 5. So 75 degrees. All right. What's another one? Dominic. 7 is good. What does it intersect with? 40. So we're going to do 40 divided by 2, which is 20 degrees. Good. So 7 is 20 degrees. What's another one? Trinity. 3 is good. What's the arc that it intercepts? Good. So it's going to be the exact same as 7. So it'll be 20 degrees. Still got a couple more. What's another one, Davis? 2 is. It is with the tangent line. What's the arc that intercepts? It does. So it'd be the same thing as 13, 4, and 6. So it'd be 42.5. What's another one? What's another one? Jordan. So Jordan, look at the angles that we have left. So 9, say it again. 9 is, good. So 9 is, what's the arc that intersects? 85, good. So that would also be 42.5. So 42.5 goes to 13 and 9. All right, what's another one? Marley. 10 technically is not, but there's one close to it that is. It'd be 8. All right, what arc does it intersect? Not 85. Look at for the ice cream on top of the cone. It'd be 150. Good. So it would be the same as 14 and 5. So it'd be 75. Now, that's all the inscribed. So that leaves us with our others. So 12, 15, and 10 are our others. All right. So name me how I can find one of our others. Let's go Shakib. Say again. Okay. Let's look at 15. That's probably the easiest one. What's a theorem that I can use, whether it's a triangle or linear pair theorem that I can use to find 15? Say again. Linear pair. All right. What's it a linear pair with? There's two angles that it combines together to get a linear pair. Well, 1 and 2 is for a triangle, but we can use that to, it's the same thing pretty much. So let's use the triangle. So if we take, for 15, we're going to use the triangle. And if I use 1 and 2 to find 15, what do I have to do with it? Add them together and then do what? Good. So I'm going to do 180 minus 75 minus 42.5, which would give me what? It's what? 42.5. Good. 62.5. That's what 15 is. So this is 62.5. All right. Now, help me solve one of my other angles. Not here. Anna. So either 12 or 10. You can pick whichever one you want to do. Okay. So how would you find 10? So we can't use one of our angle theorems, but we can use like either linear pair or triangle. Which one would make the most sense? Linear pair. So it's a linear pair with 9 and 8. So we just add up 75 and 42.5, subtract it from 180. So in reality, angle 10 is going to be the same, even though it's a linear pair, it's going to be the same as 15. So it would also be 62.5 degrees. All right, last one is angle 12. Help me out with that. Not here. Mahogany. Subtract what? So look at where 12 is. Could I use a triangle or a linear pair to help me find it? Okay, we can use a linear pair. It's a linear pair with 14 and 13. So how would I find it? Say one more time.
The same as the other two.
Right, the same as the other two. So 12 will be the same as both 10 and 15. So it'd be 62.5. And we have now finished the big circle. So guys, when it comes to these, if you notice, there was a lot of repeating. All right. So once you find a couple of angles, what you'll start to discover is that once you do the work for some of them, the work repeats. So you don't have to keep doing the same work over and over again, as long as you can recognize which arcs that's intercepting, as well as what properties is happening to it, whether it's a bow tie, a beak, inscribed, or just one of the other ones that we just have to do at the end. So the order of which you do them doesn't matter. The only thing is make sure you do your others at the end. So the ones that are clearly not inscribed or bow tie or beak, make sure you do those at the end once you have all your other angles figured out. Any questions on that? All right. So the last thing I want to do today is I want to start to get into 6.5. So you're going to need your journal out. And you're going to go to that first 6.5 foldable. So it's the one labeled arcs and chords. So it should be the next one that we haven't done in your journal. All right. Now we're just going to start 6.5. We'll finish it tomorrow because we don't really have that much time. So we can at least get through this one. Okay. So for these, we're moving away from angle measures and getting into segment lengths, meaning the actual lengths of these chords. All right. So the first theorem is in a circle or congruent circles, if two minor arcs, remind me what a minor arc is? Remind me what a minor arc is? It's less than 180 degrees. If two minor arcs are congruent, if and only if their corresponding chords are also congruent, meaning the chords that kind of mark them off are congruent. So, for example, if we look within this shape, let's label this quadrilateral A, B, C, D. What two segments are congruent? So what two segments of that quadrilateral are congruent? AB and DC. So segment AB is congruent to segment DC, and they mark that with the tick. So these two segments are congruent. We know because they put the tick there. So that means that since these two arcs, or not arcs, since these two chords are congruent, that means that these two minor arcs are also congruent. So that means arc AB is congruent to arc DC. So if you look, it's really where the segment kind of cuts off where that arc will be. So where the segment starts and ends, the arc that's formed in between the segment, that's the arc that we're looking at. All right, so let's look at questions 1 and 2 on the inside. So it says, if segment AB is 5x and CD is 3x plus 6, find AB and CD. So we're trying to find the lengths of them. All right, now, what's going to be true about those two chords? So look at these segments. So if we actually dot off the points, what's going to be true about those two chords? They're going to be what? Congruent. Why? Why are they congruent? What clues us into that? Right. See these See these minor arcs right here? 127, 127. Since they are congruent, that means that the segments are congruent. So how would I set this up to solve for x if they're congruent? 5x equals 3x plus 6. So I'm going to subtract the 3x over. I get 2x is equal to 6. So x is equal to 3. Now I'm not done because what did it ask me to find? A, B, and C, D. Now, we know that they're congruent, so it really doesn't matter which one we plug back into. My recommendation, do the easier one. Which one do you think will be the easier one to plug back into for x? The 5x. So AB is equal to CD, which is 5 times 3. So their length is 15. Now, if you want to do a quick check, you can also throw 3 into the other expression. Make sure you also get 15. So 3 times 3 is 9 plus 6. That is, in fact, 15, so it works. Now, number 2, it says find the value of x. So x is connected to the length of this segment right here. Now, the other 3 sides have already been found. Which side would make the most sense to set that segment length equal to it? So we know we're going to start with 12x plus 2, or minus 2. What are we going to set it equal to? 34. Why? Because they're congruent. Why? Because their arcs that they form are congruent. Ladies, shh. So I'm going to add 2 to both sides. 12x is equal to 36. Divide by 12, x is 3. If we double check our work, 3 times 12 is 36, minus 2 is 34, works. Any question on the first theorem? All right. Let's look at the second theorem back on the front. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. What does bisect mean? Cut in half. Bisect means cut in half. So, right here we have a radius. And it's perpendicular to this chord. So let's call this radius AB and then the chord CD. And then where they intersect, let's just call that E. So since AB is perpendicular to CD, that means that DE is congruent to EC. So this little segment's congruent to this little segment. And so that leads to this. And arc DB is congruent to arc BC. So those measures are the same. So as long as that radius or diameter, so again, AB has to be a radius or diameter. In this case, it's a radius. And CD is the chord. As long as those two are perpendicular, meaning they form a 90-degree angle, then the radius bisects the chord. And it also bisects the arc. So let's look at some problems with that. All right, let's look at 3. So given that the chord BC is 15 centimeters from the center of the circle, which has a radius of 25, find BC and DE. So BC is 15 centimeters from the center of the circle, meaning if I drew a line from the chord BC to the center A, that length is 15 centimeters. The radius is 25. All right. So the radius is AB because it's from center to the end. That's 25 centimeters. What other segment is also considered a radius? AE. So AE is also considered a radius, and it's 25 centimeters. And they want us to find BC. So they want us to find this entire length. Let's call that X. And they want us to find DE. So this little segment right here, let's call that Y. So which one would be the easiest one to find right now? Which one takes the least amount of legwork, X or Y? What do you guys think? Which one's the easiest to find? Come on, guys. This one's obvious. Y is the easiest to find. Why? Why is it easiest to find Y? So we got the full radius, which DE is a part of. It's 25. We also got the little piece of the radius AD, which is 15. So we can just subtract them to get Y, which is what? 10 centimeters. So DE is 10 centimeters. Now, X. How would I find X? So that's the full chord length. But to do that, I need to find what first? So remember, these two little pieces are congruent to each other. So I need to find what first? I need to find BD first. So I need to find this segment first. How? Pythagorean theorem. Good. This right here is a right triangle. I got two sides of it, so I can do Pythagorean theorem. So a squared plus b squared is equal to c squared. So I got x, well, not x squared. Let's do bd squared plus 15 squared is equal to 25 squared. So this would be bd squared plus 225 is equal to 625. So bd squared is equal to 400. And then what's the square root of 400? 20. So that means this little piece right here is 20. So if that little piece is 20, what's the length of DC? Also 20. Thus, what's the length of BC? 40. BC, you would do 20 plus 20, which is 40 centimeters. So there's your two answers. All right, let's look at number 4. So it wants to find the length of AD and CD and the measure of arc AB. So we got a radius CE. It's perpendicular to a chord, so that means these two pieces are congruent, as well as these arcs are congruent. So if we want to find arc AB, that'll probably be the easiest one to find. How can I do it? What'd they give me? What arc can I already get an answer to? AE. Why? It's a central angle, so it's congruent to this angle 60. So this is 60 degrees. Which means that EB is also what? 60 degrees. So that means AB is what? 120 degrees. Just add them together. Now, they want AD and CD. Now, this one's not as obvious, so I'll kind of tell you how to find it. This one, we have to use a special right triangle. Specifically, a 30, 60, 90 triangle. So if you have a 30, 60, 90 triangle, so this is 90, 30, 60. 30 we would call X. The hypotenuse would be 2 times what we call the short leg. And 60 would be X square root 3. So we call the one across from 60 the long leg, the one across from the 90 the hypotenuse, the one across from the 30 the short leg. So 30 degrees would be right here. They gave us which side? What side did they definitely give us in that right triangle? The hypotenuse, 6. So whenever you do these special right triangles, you always got to go around using the short leg as the middleman. So how can I get from the hypotenuse to the short leg, or CD? You divide it by 2. So CD is 6 divided by 2, which is 3. So that's equal to 3. Then, to get to AD, I just got to multiply 3 by the square root of 3. So that's the length of AD, 3 square root 3. And we'll leave it as the 3 square root 3. So that was review from Math 2. You learned about special right triangles way back in Math 2. All right. Last theorem. In a circle or congruent circles, if two chords are congruent, if and only if they are equidistant from the center. Equidistant means what? Same distance. So equidistance means they're the same distance from the center of the circle. So if we look here, let's call this chord AB, this chord CD. Let's call the center E. So if you notice, they drew from a point on the chord to the center of the circle. And they said that they're congruent. Since those two segments are congruent, that means that AB is congruent to CD. That means these two segments are congruent. Now, where that will come in handy is at some point, notice how they did 90-degree angles here? So they drew perpendicular lines. They may ask you to connect a line to form a right triangle. So that's kind of where you may see that. And where there's a right triangle, you got Pythagorean theorem. All right. So for 5, FG is 3, GA is 5, AH is 4. Find PJ, which is here. We'll call that X, and LA, which is here. So I first need to determine if they're equidistant, meaning because they don't mark them as equidistant. So we can't say they're congruent until I know for sure. So if they're equidistant, that means that I can use what theorem to find GH? I need to find GH first. Pythagorean theorem. So this will be GH squared plus 4 squared is equal to 5 squared. So GH squared is equal plus 16 is equal to 25. So GH squared is equal to 9. So GH is equal to 3. So they're both equal to 3. So what does that say about those two chords, PJ and LA? They're equal. So these two chords are equal. Now, if you also look, what happens right here? So if you notice, these are all radii. So if I draw this one, this will be 5. So this is 3, this is 5. What does this one have to be? 4. So what's the length of LA? 8. That's the same thing as PJ. So PJ is equal to LA, which is 8. All right, last one. We can do it in 5 minutes. It's quick. FG is 3x minus 4. HJ is equal to 14. They want to know the value of x. Don't start packing up yet. So 3x minus 4. HJ is 14. Now, if you notice, they are equidistant from the center. So what does that say about their chords? They're what? They're equal. So that means I can set them equal to each other. Add 4 to both sides, I get 3x is equal to 18. Divide by 3, x is equal to 6. That's all you had to do. All right, so I will say that, listen, I will say that I already assigned you the 6.5 Delta Math. You should be able to do at least a little bit of it. We still got 2 more foldables to do for 6.5, but you can probably do a little bit of it. All right, make sure you guys erase your whiteboards before you leave.